Hey students, it's Miss Manning here, and I'm going to teach you about a special property that triangles have about their interior and exterior angles. It's actually called the exterior angle theorem. That is exterior angle theorem if you want to write that down. Before we get started, let's learn some vocabulary. So just like when we had interior and exterior with parallel lines, if you'll recall when I have a parallel line, I have the interior, it's on the inside, and the exterior is on the outside. It's the same way when we're talking about how to name the angles of a triangle. So here in this corner, you'll see my figure. Okay, I have a triangle here. The interior of the triangle is the inside of the triangle, and the outside of the triangle is the exterior. Okay? So interior and exterior, very simple. And so that's actually what we use to name our angles. So when I'm talking about an interior angle of a polygon, of any polygon, or here specifically a triangle, the interior angle is the angle on the inside. Okay, so angles 1, 2, and 3 are interior angles. Exterior angles are angles that are on the outside of the polygon, or here of the triangle. So 4, 5, and 6 are my exterior angles. There are actually more exterior angles for this shape than are pictured here. Let's see if we can determine the defining characteristic of an exterior angle. So if you'll notice, each of these exterior angles makes a linear pair with the interior angle. So there 4 and 1 have a linear pair right there. 2 and 6 form a linear pair right there. And 3 and 5 form a linear pair right there. So if I was looking for other exterior angles for the polygon, if we were to extend the line here, we would notice that 3 and 5 are a linear pair, but also 1 and whatever this angle is here, we could call it angle 7, are a linear pair, right? If I draw the line out this way, we have 2 and 6 is a linear pair, but so is 3 and can call it angle 8. Angle 8 is a linear pair there, right? And same thing if I drew the line out here. Okay, we have 2 and 6, 1 and 7, 4 and 1, 3 and 5, 3 and 8, and then 2 and 9 right there. We get that extra linear pair right there. So again, maybe we should write that down. It's a very important definition. An exterior angle of a triangle is an angle that forms a linear pair with an interior angle of the triangle. Very important to write down. You can pause and write that down right now if you'd like. Okay, also, let's talk about what remote interior angles are. This sounds very difficult, but it's actually quite simple. Here, remote means like far away, or the angles that are farthest away. If a celebrity goes on a vacation to a remote location or a remote desert island or whatever, we're talking about an island that is really, really, really far away. So here, if I'm looking at exterior angle 4, the remote interior angles to angle 4 are the angles that are farthest away. That is angle 2 and angle 3 are the remote interior angles because they are the angles that are farthest away from angle 4. Notice also here, they are the only angles that are not adjacent to angle 4. Angle 1 and angle 4 share this ray, so they're adjacent, but angle 4 does not share anything with 2 or 3. Okay, so sometimes instead of remote, we hear the word opposite interior angles, because they are not adjacent. Okay, they are not adjacent, so they are opposite. Okay, but typically the verbiage used is remote interior angles. Okay, so if I was looking at exterior angle 6, the two remote interior angles are angle 1 and angle 3. If I'm looking at exterior angle 5, the two remote interior angles are angle 1 and angle 2. Okay, and so hopefully that makes sense for you. Okay, if not, you can rewind. I'm going to go on. Let's look at a real-world application here if we had this triangle here. So let's say we have this shape. We know that the measure of angle 5 is 147. And we want to find the measure of angle 1. So we're looking for angle 1. Okay, there's a ton of ways that you could think about solving this. Let's go through the most obvious. Well, we know that angle 5 is a linear pair with angle 2, right? We see that right there. We see the line. Okay, if you have trouble visualizing it, we can just, we can clone the shape. And if I rotate it, you see right clearly right there, we have that line, right? That linear pair, 180 degrees. Okay, so we have that linear pair. So now we know that angle 5 plus angle 2 is 180. Okay, all right, and so we can substitute in angle 5 is 147. Angle 2 is unknown. Okay, so we subtract 147 on both sides. And we get that angle 2 equals 53. I'm sorry, 33. 33. Right, 47 to 50 is 3. 50 to 80 is 3. So 33. So angle 2 is 33 degrees. Okay? Well, now we can very easily solve for angle x because we have a triangle right here. See this triangle? So we have this triangle. We have two of the angle measurements. This is clearly 90 as denoted by the little box there. And so we have that angle 2 plus angle k plus angle x equals, or you could say angle 1, 180. All right, angle 2 is 33, angle k is 90. We don't know what angle x is. Okay, so we just solve 90, 100, 10, 20, so that's 123, plus angle x, or just x, is 180. Okay, minus 123 on both sides. 57 degrees. So x is 57 degrees, right? 23 to 30 is 7. 30 to 80 is 50. So 57 degrees. And so now we've determined that angle x is 57 degrees. So there we go. We solved the problem, right? Seems simple enough, but there's actually a much easier way to solve the problem. And if we look at these two statements, angle 5 plus angle 2 equals 180, and angle 2 plus angle k plus angle x equals 180, we see something very powerful there. What we see is that these are both equal to 180. So we can go back to our algebra, our understanding of algebra things. If this equals 180, this equals 180, and this equals 180, then they must be equal to each other. So what that is if we rewrite the statements, so it's angle 5 plus angle 2 equals 180, right? That's our supplementary pair or our linear pair. Okay, and then it's angle 2 plus angle k, this is our 90 degree angle, plus angle x, or angle 1, right, equals 180. Well, then we can just set these equal to each other, and let's see what we come up with. So angle 5 plus angle 2 equals angle 2 plus angle k plus angle x, or angle 1. Okay, these two can be marked off, right? If we subtract angle 2 on both sides, they go away. Okay, so we get angle 5 equals angle k plus angle x. Now this is a very powerful mathematical statement. What we've just shown is that for this triangle, angle 5, this angle right here, is equal to angle k plus angle x. Angle k plus angle x. Now, why does that make sense? Well, look at it and think about it logically. If angle 5 is forming a linear pair with angle 2, that means that they add up to 180. Well, but angle 2 also adds to angle k and angle 1 to make 180. So in order for that all to be true, it must mean that 147 is equal to 90 plus x, right? 147 equals 90 plus x, right? And let's see what happens when we subtract 90. Right, 90 to 100 is 10, to 40 is 40 to 7 is 57 degrees. There we go. We ended up with the 57 degrees again, right? And notice 90, right? 90 angle K plus angle 1 or angle X plus 57 equals angle 5, 147, right? That's 147 equals 147. We have a true statement. So what did we just show? We just showed that angle 5, the exterior angle here, is equal to the sum of, right, this means addition, the two remote interior angles of the triangle, right? Because that's what we actually have right there. If we take a look at this shape, right? Here's our exterior angle, angle 5. And what are the two remote interior angles? Angle 1 and angle K. Those two are equal to, the sum of those is equal to angle 5. Okay, this is a concrete example. Now let's look at it algebraically, algebraically. So here are three intersecting lines, and let's say we have angle X, angle Y, and angle Z, and then we have exterior angle W. Okay, well again we have that linear pair. Right, here's the line. Okay, so we see, what do we know? Z plus W equals 180. We also have our beautiful triangle, this guy right here. So what do we know? X plus Y plus Z equals 180. There it is again, right? This guy equals 180 and this guy equals 180. So that must mean that they are equal to each other. That is called the transitive property of equality. If A equals B and B equals C, then A equals C. It's the transitive property of equality. Okay, so here we just put them equal to each other. Z plus W equals X plus Y plus Z. They both equal 180, so we can set them equal to each other. Well, look at what happened again. These are both on the same side, or I mean on different sides of the equation, so we can just subtract them off, right? They go away. They're gone. So W equals X plus Y. This is our mathematical truth, that the exterior angle W is equal to the sum of the two remote interior angles. So this is our exterior angle, and these guys are the two remote interior angles of the triangle. Let's look at it formally. Exterior angles of a triangle, and this is a theorem. We have theorems in geometry. The measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So here, this is, if we said this was angle 2 and this was angle 3, angle 1 equals angle 2 plus angle 3. Over here, they defined them as the measure of angle A and the measure of angle B, right, is equal to the measure of angle 1. So that means whenever I have something here, I can set it equal to the sum of the two remote interior angles. Okay, and now you're going to use this idea to, an application of this to actually quite difficult problems, much more difficult than we've looked at here. But I think you're definitely ready for it. You can review any parts of the video. Feel free to raise your hand and ask a question if you're confused, but you don't have a lot of time. So thanks for listening and good luck.